A fundamental type of question that chemists might ask is how many? How many molecules of water can fit in a glass? How many atoms of carbon are there in a sugar molecule? How many acidic or basic ions are there in a certain amount of solution? To answer these types of questions, we use a certain type of accounting that might seem strange at first, only because 1 plus 1 plus 1 sometimes equals 1. To show you how this might work, let's imagine a flight of CF-118 Hornets, and we'll use 410 Squadron because we want the two-seater variant. Here we have one crewed aircraft getting ready for launch. To get it into the sky, it's going to take a jet and two pilots, a student and an instructor. In other words, we'll need one jet plus one student plus one instructor to get one flying aircraft, or 1 plus 1 plus 1 equals 1. If the squadron has 12 jets, each with two pilots, they could launch a dozen aircraft. To get 1 dozen flying planes, you need 1 dozen aircraft and 2 dozen pilots, or 1 plus 2 equals 1. We know that when we say 1 dozen, what we mean is 12 objects. It's just a number that simplifies counting. Usually eggs or donuts, but we know it could mean any object. The dozen is not an SI unit. The SI unit for amount is 1 mole. Instead of 12, 1 mole equals exactly 6.022140076 times 10 to the 23rd power objects. Anything. We could have a mole of donuts or a mole of eggs, but they would be the size of the moon. We need a unit that big because atoms are so small. It really doesn't take a lot of matter to make several moles worth of atoms. For instance, there are more atoms in the tip of your smallest finger than there are stars in all the galaxies in all the universe. To illustrate further, let's talk about a mole of water. So of course this is the obligatory mole pun. It's funny, I didn't even know moles could swim. Oh, no. Oh, gosh. No, let's forget that, if you can, and we'll stick with actual water. So a water molecule contains 1 oxygen atom and 2 hydrogen atoms. So 1 mole of water contains 1 mole of oxygen atoms, or 6.022 times 10 to the 23rd power, and 2 moles of hydrogen atoms, or 1.220 times 10 to the 24th power. All told, that's 1.807 times 10 to the 24th power of atoms. And all that can fit in a tablespoon.